Hi everybody. In this video, we are going to create a very simple Java program. So our goal here is to just try and begin to understand how programming in Java works. Um, I won't be going into too much detail with a few of the concepts here. Um, our goal here is to just go ahead and create a working program. And then in future lessons, we will go ahead and take a look at some of the other stuff in greater detail. Now, of course, I will still be explaining some of the things, but it's not going to be a complete explanation of all the concepts because we're never going to finish if we do that. There's just a lot of things to explain. So let's just go ahead and get started. So I have my text editor here, and then I have a folder called BankAccount-sample. So this is where I will be placing my Java files. So I'm going to create a new one. I will name this one bankaccount.java. So here it is, and then here is the document. And then I'll go ahead and declare what's called a class. So this is the class declaration. So you say public class, and then the name of the class, which in this case is bank account. It has to be the same name that you give here. Otherwise, you're going to get an error. And then the body starts and ends with curly braces. You have an open curly brace and then a closing curly brace. So they mark the start and the end of the body here. So inside here, I will declare what are called fields. So I will say private double balance, and then private string account name. So these are called fields. So a field is a characteristic of an object. So what we're doing here is, when we're making this class, we are creating the blueprint of what a bank account is supposed to be in the context of our program. So this is kind of like the design of what a bank account should be. So what we're saying here is, for every bank account that we make in the program, each bank account has to have a balance and an account name. So those are the very simple characteristics of our very simple bank account class here. So if I make, for example, one bank account, it's going to have a balance. So let's say this bank account I'm making, this new one, has a balance of 2,000. And then it has an account name of Alice. So those are the values for these two fields. So that one bank account has a balance of 1,000 and an account name of Alice. So this is Alice's bank account, and Alice has 2,000. And then we make another bank account. So this other bank account, this second bank account, is going to have a balance and an account name as well. So let's say this one has a balance of 1,000 and an account name of Bob. So now we have two bank accounts. Both of them have a balance and an account name. The second one has a balance of 1,000 and it belongs to this guy named Bob. So those are what fields are in sort of like a very simple way of looking at it. So when you make fields in Java, usually you will say private. Now, we will not discuss this in detail right now. Maybe later or maybe in a future lesson. And I don't know, I think you hear my neighbor's kid crying again or shouting. Yeah. So every time I make a video, he wasn't shouting the whole day, except now when I try and start making a video. Always. So let's see. So where was I? So when you make a field, so for now, just always make it private. Okay. And then you specify the data type as well. Okay. So this is not something that we would do in Python. In Python, when you make a variable, essentially these are variables, these fields. You would just say x is equal to 5, right? And you won't even end with a semicolon. You just say x is equal to 5, then you go on to the next line, and then you make a new one, right? In Java, you would specify the data type as well. So this is the variable name. This is the field name. So this one, you decide what to name it. So for this one, I've named it balance, just to be more descriptive. And then this is the data type. So this means that the balance field, the value of it should be a double. Double meaning a double precision floating point. So balance is equal to 1000.45, for example. Balance is equal to 531.64. Okay, so those are double values. So we can't give this, for example, balance is equal to hello world. Because hello world is obviously, it is not a double precision floating point value. So we are going to get an error if we try and actually compile this. So again, this is not something that you do in Python. In Python, you could actually have a variable that previously had an integer and then after that had a string. So here in Java, if you declare a field and then specify the data type, so it is going to be choosy with what values you're allowed to put in there. You can, however, give it an integer. So this is fine because an integer is also a number, and it fits inside a it fits inside a variable for a double because an integer has less information. So if I do this, it's just gonna get converted to 1000.0. And this one is a field named account name. So this one is supposed to store a string. So we can give it, for example, Bob. Okay. But we will actually not give the values here. Because if I give the value here, so this means that every time we make a bank account, this means that the account name should be Bob. So all of our bank accounts, if we made 1,000 of them, they'll all have an account name of Bob. So what we're saying here is a bank account has to have a balance and an account name, but we're not giving it any values yet. We're going to give the values when we actually create the bank account. So for every bank account that we make, we could give it a different value, give it different values for these fields here. So how do we do that? We're going to need to create what's called a constructor. This is a comment, by the way, a single line comment, 2 forward slashes. So here is the constructor for my bank account class. Okay. So you say public. Okay, so for now, again, just accept that you type this. And then the name of the class has to be the same. The name of the file, the name of the class, and the name of the constructor must be the same. You are going to get an error here if you just miss a character or something. And then followed by parentheses. And then inside here, optionally, you could put parameters. So we already know what parameters are, right? We learned that in Python. And then the body of the constructor. So again, you use curly braces. Okay. So this would be the body of the class declaration. And then inside it, you have stuff. And then this is the constructor. And then you have the curly braces. They're a bit. My neighbors are a bit distracting. I don't know if you guys can hear it, but I am getting distracted. I'm finding it a little bit harder to concentrate. But I want to get this video out as soon as possible. So we're just gonna keep those things in. So I'm sorry about that. But yeah. So where was I? So this is the constructor. So a very simple way of looking at this is, for now, we can just say that this is the thing that allows us to make the bank accounts. So it constructs the bank accounts. So that's one simple way of looking at it. It's not exactly 100% like accurate, but for now, I think that's a good definition. So this is the thing that allows us to construct or create bank account objects. Now, I mentioned that you could have optional parameters here. We are going to put some, because we want to be able to specify a balance and an account name every time we make a new bank account. Okay, so because we want to do that, then we're going to put parameters in here. So let's say string, and then I'm just going to name this one n, short for name, account name. And then this one is going to be a double. So I will just name it B, short for balance. So when we call the constructor, the bank account constructor in this case, this means that we should pass to it a string like Alice or Bob or Kathy or whatever, and then a double. 5,000, well, we can pass integers, it's fine. 5,000, 4,000.35 or whatever, okay? So when you declare parameters in Java, you specify the data type as well. So in Python, we would just say n comma b. So in Java, we would specify the data type. So this means that the first parameter needs to be a string, and the second parameter needs to be a double. So we can't change this up. We can't give it a double and then a string. It's gonna cause an error, because if you try to fit a double inside a string, it's not gonna work. And if you try to fit a string inside a double, that's not gonna work as well. So you have to make sure that you follow the same order that you see here. So when we receive those values, so let's say we call this constructor. We say, let's make a new bank account, and then n will be Alice, and then b will be 2,000. We then need to assign those values to the fields. So n, the value of n goes to account name, and then the value of b goes to balance. So what we will do here is we will say account name, which is the name of the field, is equal to n. And then we will say balance is equal to b. So whatever value we pass to n will then get assigned to account name. And then whatever value we have for b will then get assigned to balance. So at this point, it's probably confusing. You might be wondering, why do we not just directly assign the values here? So we'll go ahead and explain that and try to understand that later when we actually make the bank accounts themselves. So this is later on when we're done with the other stuff, and then we can go ahead and test it already. Okay, but for now, so this is the constructor. It allows us to construct or create the object, and then also initialize the values for the fields. Okay, so let's make a new bank account. Let's initialize it with an account name of Alice and a balance of 1,000. Okay, so what are we going to make next? After this, we're going to make what are called methods. So a method is a function, basically. So we're going to be making functions. So these are the things that a bank account can do, or whatever object we're trying to design. You can think of methods as the things that they can do, or the things that can be done to them. So if we have bank accounts, what are the things that a bank account can do, or what are the things that we can do to a bank account? We can check the balance, like how much money do we have, or how much money the bank account has, whoever owns it. We can also retrieve the account name. We could also deposit and withdraw. So these are things that we can do with the bank account. So we would define that behavior using methods. Okay, so the methods are, as I've said, they're functions basically. So let's create the first one, which is going to be the deposit method. Okay, so I will say public void deposit, and then I will give it a parameter, just one. It's going to be a double. Sorry about that. And I'm going to name it AMT, short for amount. So we've got a method here, which is essentially a function. So kind of different from how we would write it in Python. So in Python, you would just say def and then the name of the function, and then in parentheses, you would have the parameters. So this one, for now, so every time we just make a function, we make it public, or a method rather. Well, a method is a function. So every time we make a method, we make it public, okay? So a method is a function. It is a type of function that you call on an object. We've learned a bit about this in Python, actually. If you remember, we could append to list objects, right? So if you have a list called x, and then you could say x.append, and you would say hi, for example. So this adds append adds this element to the list object. So this is a method in this case, which is a function that you call on an object. So that's what we're making here, except that this would be like the Java version of it. So, okay, so for now, every time we make a method, let's just make it public. Now, this one is the return data type. This one is void. Not all of them will be void. This one is void, which means that this method is not going to return anything. It's just going to do something, but not return a value. So we're familiar with return, right? We're familiar with the concept of functions with return statements in Python. So you could call a function, and then the function is going to end up returning a value to the caller. So you can also do that in Java. But when you say void, this actually means that this particular method is not going to return anything. It's just going to do stuff, okay? So in this case, the only thing what this will do is it's going to deposit to the bank account. So when we call this method, deposit, we are going to have to specify a value as well, and it has to be a double. So this is going to be the amount that we want to deposit into the bank account. So you could say, for example, deposit 500. So amount is equal to 500 in this case. You can say deposit 1000.23. So amount will be equal to 1000.23 in that specific call to the method. And then once the method is called inside the body, what do? We want to go ahead and add that amount to whatever the current balance is. So we say balance plus equals AMT, right? So get the current value of balance. So let's say the balance is 1000 and then AMT is 500. So get the current value of balance, which is 1000, and then increase it by 500, which is the amount, and then make that the new value of balance. So the balance now is going to be 1500 for that specific bank account. So you can think of these fields as sort of like the things that keep track of the state of the object. So if we create a bank account and it's got a balance of 5,000, then at that particular moment in time, the state of that bank account is that it has a balance of 500. And it has an account name of, well, whatever the account name is. And then later on, we call the deposit method to add more money to the bank account. So if we add 500, so that changes the state of the bank account. That particular bank account, the balance has now increased. So it's now different from before. So if it used to be 4,000, for example, if you add 500, so it's going to be 4,500, and that value is going to be stored here in balance. So next we make a withdraw method. So let's name this withdraw. And then this one is going to have one parameter as well, which is going to be the amount that we would like to withdraw. So, I think I should probably explain what are the things that we can change here. So, in this case, you can change this name. You can give it a different name if you want, like add money or something. This one, take money. Okay, but we're gonna stick with deposit and withdraw. Okay, so you can give this whatever name you'd like, as long as it follows the rules of making method names and it's not in conflict with other names. And then this one, for now, we just go ahead and follow that. Every time we make a method, let's make it public. And then if that method is not going to return anything, we say void. And then you can also change this. So you can give it a different name if you'd like. So again, a parameter name is a variable name, right? So it's author defined, so you decide what to name it. And then this one you can change also, but you can't just put anything you'd like here. It has to be an actual data type. So in this case, if we want the amounts to be a double precision floating point, so we say double. If we want to pass a string, then we say string instead, all right? So those are the things that you can change. This one, and this one, and this one. And of course, inside the body, so this is where you decide what statements you'd like to put in there. So the statements will be the instruction set will carry out what you mean for this method to do. So this particular method, the withdraw method, is supposed to reduce the balance, right? It's supposed to take money from the balance. So here we say balance minus equals AMT, okay? So whenever we call the withdraw method, we need to pass a value to it. Withdraw parentheses 500, for example. So it's going to subtract 500 from the current value of balance and then make that the new value of balance. So if this particular bank account has a balance of 3,000 and then we withdraw 500, so at the end of that transaction, the balance is not going to be 3,500. Okay. So in terms of what we've learned in Python, I guess you can think about these as global variables. So you remember global variables in Python? Those are variables that you can access from anywhere. From within functions, within methods, you'll be able to see or access these variables. So account name balance is written inside this method. A constructor is a method as well. It's a special type of method that we use to create the object. So there's going to be no problems here. Account name and balance will be able to access the account name and the balance fields. So same thing for this one. And then the parameters are local. So again, same concept that we've learned in Python. So this one is local to the deposit method. So it's not going to get confused with this one. So when you say AMT in here, it's going to refer to the value of AMT for this one and not this one, because this is a completely different method. So this AMT is going to refer to this one. Now, if we try to access N and B from within here, so it's going to give us an error. So we can't say N, print it out, or give it a new value, okay? So the concept of local and global variables. So quite similar, except in Python, you can't actually just change the value of a global variable from within a function, if you guys remember. So in Java, we could easily I could just go ahead and say balance is equal to 500. So from within this method, I am changing whatever the value of balance is here. But in Python, you actually can't do this. In Python, well, you can't do it directly. In Python, you're going to have to say global and then the name of the global variable and then assign to it a new value. But in Java, you can just go ahead and modify the values of your global variables, your fields, from within your methods. So balance plus equals amount is perfectly fine. In Python, what you can do directly would be like the print statements, right? So in Python, you could just say print and then the name of the global variable. You can do the same thing in in Python, or in Java rather. So let's say we also want to print out the value of balance after this one. We can go ahead and do this. Okay. So when we call deposit, it's going to increase the balance, and then it's going to go ahead and print out the balance as well. So this is how you would print something in Python, or in Java rather. Sorry about that. But we will not do that here. Instead, we are going to create two more methods. So we'll create methods that will allow us to actually access the values that we have here. So what if we want to check the balance? Okay, so let's make a method for that. So we make this public, but now this time we have to specify a return data type. So if I want to get the balance, then the return data type has to be the same as the data type of this field. So because this field is a double, this method has to return a double as well. So you specify the return type here. So again, you don't do this in Python. In Python, you actually just make the function, and you don't need to specify whether it should return a string or a double or a floating point number or a boolean. Okay, but in Java, you would specify it. So I'm going to name this one get balance. And then it's not going to have any parameters because I really just want to get the balance. That's all I want to do for this method, I mean. So public double, okay? So this one you can change. So you change this to whatever data type you want to return. Yeah, so whatever value you want to return, what is the data type of that? And that is what you want to specify here. So if you want to return a string, then you say string. If you want to return an integer, then you say int. This one you can change as well. You can name the method whatever you like. As long as it doesn't break any of the variable naming rules and there's no conflict with other names. Okay. And then here you could put parameters if needed. But for this specific method, we do not need any parameters because again, the only thing you want to do here is you want to get the balance. So how do we actually return the value then? So it's actually the same as in Python. You say return, and then you say return balance, and then semicolon. So whatever the value of balance is going to be returned whenever you call this function. So when we say get balance, when we call this, it's going to check the balance of that specific bank account, and then it's going to return that value. So whatever that is. So let's say the bank account has 5,000. So that function call is going to return 5,000. And then finally, let's make one that returns the account name so that we can actually go ahead and access the account name. And then we say return account name. So the reason why this is a string, the reason why this says string is because I mean to return account name, and the data type of account name is string. So it has to match. If it does not match, then you will get an error. And then this one, sorry, I will name this get account name. Right, so there. So get account name will return the account name, the value of the account name field. Okay, so yeah, I had to change this. You should not make your method name the same as the field name because that is confusing, right? Plus, I think you will get an error if you do that. Okay. All right, so this is our class actually. So a couple of things you can change here. So if you think about it, we can just keep withdrawing money. So even if we have even if we only have 1,000 left, the program actually allows us to withdraw 1,000,000. So we'll go ahead and fix that in the future. But for now, this is our class. So a class essentially defines the characteristics of an object. So our bank account has a balance and an account name. And it specifies the behavior of that object as well. So what are the things that a bank account can do? We can deposit in a bank account, we can withdraw, we can get the balance, we can get the account name. And then we have the constructor, which allows us to create the object and initialize the fields. So when we make the object, what are the initial values that we want these fields to have? Okay. So you can think of fields as adjectives. They describe the object. And you can think of methods as verbs. They are the actions or the things that an object can do, or the things that can be done to an object. So let's save this. One thing you might be wondering, why do we have to make a method to return the balance and the account name? Why can't we just directly access the fields here? So this has to do with this thing that says private. So we will explain that in the future. But again, for now, there's a couple of things in here that you just accept for now. And then we will try to understand them more in future lessons. Okay. So now we have this class. Next, let's create another Java file, which is going to serve as the tester. So we can go ahead and test this class. So I'm just going to go ahead and make a new one. And I will just name it BankAccount Tester. So now we've got two files here. So let's go ahead and declare the class. And then this one is going to have the main method. So it's going to say public static void main string args. So we've talked about the main method already in the previous synchronous session and also in the slides, and I think in one of the other videos, the Hello World video, I think. All right, so let's save this, and then let's go ahead and okay, let's go ahead and split this so we can see both of them. BankAccount Tester, BankAccount.java. All right. So they're both in the same folder. So this means that I will be able to access the public stuff inside this class from here. So I could, for example, say, I could call the bank account constructor because it's public. So what I'm going to do first here is I'm going to create a new bank account. So first I will declare a bank account variable. So I will say bank account B1 is equal to, and then to be able to create a new bank account object, we use the new keyword, and then we call the bank account constructor. So we say bank account, and then so what are the things we need to pass? We need to pass a string and then a double. So let's just say Alice, and then 2000, and then a semicolon. Okay. So if you want to create an object, you use the new keyword followed by the constructor. All right. So of course you have to make sure that you define the class first. We had to create the bank account Java class first, and then we made a constructor here. We defined the fields and then the methods. So now we can go ahead and make one. So new bank account calls this constructor, and then Alice gets passed to N, and then 2000 gets passed to B. And then that makes a new bank account. Well, N is Alice, and then that gets assigned to account name. So it goes here. And then B is 2000, and then we say B should go to balance as well. So now balance is equal to 2000. So this specific bank account that you see here, okay? So we'll explain that later, but maybe I'll make some illustrations. So what we're doing here is we're creating a new bank account object. So it's going to be Alice's bank account with a balance of 2,000. And then we're assigning it to a variable. So we need to give it we need to assign it to a variable so we can actually work with the actual object, right? Because if I just say new bank account, so this creates a new bank account, but there is no variable name to identify it from within this method. So we create a new bank account, but then how are we going to work with it? Because there's no identifier in here. So that's why you have to assign it to a variable. So this is the variable name. So I'm naming it B1, and then equals, meaning I'm assigning this object to the B1 variable. And then remember when I said that in Java you specify the data type of the variable? So that's what we're doing here. So this B1 is supposed to store a reference to a bank account. So the data type of that is bank account. So you have to say bank account when you declare the variable. Okay, so we're declaring a variable named B1, and then the data type of this variable is bank account. And then here we're creating a new bank account, and then we're assigning it to B1. So inside functions or inside methods, you do not say private or public. So notice that none of the variables here are being declared as public or private. So you do not do that inside a method. Okay. So when you declare a local variable, okay, a local variable meaning it is local to a specific method, you just go ahead and say the data type. You don't say private or public. So if you do that, you're going to get an error. So you don't need to say if it's public or private, because it is automatic that when you declare a local variable, it's just going to be local to the specific method. So I guess it's just private to this specific method, meaning like no one else can see it from outside of this method. Okay, so that's a little bit about what private and public mean, but we'll explain that in further detail in the future. All right, so let's make another one. Let me just copy and paste this, but I will change some stuff. When you copy paste things, make sure that you double check that you've actually changed whatever you need to change. So in this case, if I forget to change B1, we're going to get an error here, because what we're doing here is we are declaring the same variable again. So Java's going to complain about that if you do that. So I have to make sure that I change this. Okay. So I'm declaring a new variable here, and then this is going to be a bank account. Okay. So this one, let's say that this one is going to be Bob's bank account. So let's give Bob 1,000. Okay. So now we have two bank accounts here. So this first one is identified using this variable B1. The second one is identified using this variable B2. So here in the next lines, if we want to work with these bank accounts, we can use B1 and B2 to refer to them. Okay, so let's do some illustrations here. Let me just bring up the thing I used to annotate, which is called Screen Brush. So all right. So line 4 creates a new bank account. So we need this class because this gives us the blueprint or the instructions on how to actually make a bank account. So you can think of it that way. It's a blueprint. Okay. So without this, then we won't be able to say new bank account because we didn't create a bank account yet. Okay. So what's going to happen here is, okay, a new object gets created. So a new bank account. I guess let's just imagine it as a box. So this is a bank account. So let's go ahead and take a look at the bank account class. So what are the characteristics of a bank account? It's got a balance and an account name. So this one is going to have a balance. It's going to have an account name as well. Okay. So we call the constructor, and then the constructor has, hold on. Oops, sorry. I am stuck in my annotation tool. All right, but let's go ahead and bring that back. All right, so okay, so new bank account, right? So we call the bank account constructor, okay? So what happens here is Alice gets passed to N, and then N gets passed to account name. So now account name for this one is Alice. So let me just go ahead and write that down here. So I'm gonna go outside of the box. Sorry about that. Okay. And then 2000 goes to B, and then the value of B gets passed to balance. So balance is equal to 2000 in this case. Okay. So we cannot directly access balance and account name because they're private. So that's why these parameters are now, as you can see, quite useful. Now, of course, you might be wondering why not just make this public. So we'll explain that in a future lesson. So for now, again, just make sure that your variables or your field names are private. Okay. So we're unable to access them from here because they're private, meaning they're only accessible from within this class. But then we also need to be able to pass these values because we want this specific bank account to have an account name of Alice and a balance of 2000. So that's what the parameters here are for, the parameters in the constructor. So we pass the values to the parameters, and then they're used to initialize the values of our fields here. All right. So so this creates that first bank account. So from within this class, from within this bank account tester class, inside the main method, this bank account is going to be identified as B1. All right. So it has a balance and an account name, and then it also has a couple of methods. So it can deposit, it can withdraw, or well, we can deposit into it, we can withdraw from it, we can get its balance, and then we can get its account name. So every time we make a new bank account, it's going to have these fields, and it's going to be able to do these things via the methods. So now when we create another one, okay, then this creates a new instance. So it's going to be a separate one, distinct from this one. So this is one bank account. It's unique. It has its own identity. And then this one is yet another one. But just like the first one, this also has a balance. And then this also has an account name. But for this one in particular, as you can see, we're actually giving it different values. We could give it the same values. Okay, they could possibly be two different bank accounts, and they both just have the same balance and the same account name. But that doesn't mean that they are the same object. They are still two different objects. So I guess it's just like a human being. There could be multiple human beings in the world that have the same name and have the same amount of money on them currently, but that doesn't necessarily mean that they're the same person, right? That doesn't mean that they're the same person, actually. That doesn't at all mean that they're the same person. So each object has its own identity. Okay, so this one, we're saying new bank account. So this creates a new bank account with a balance and an account name. And then we are using the constructor to initialize the values for those fields as well. So this one, Bob, goes to N, and then N goes to account name. So the account name for this one is Bob. And then 1000 goes to B, and then B goes to balance. Okay. So has a balance of 1000, right? So let me just draw arrows again, just so you can get a clear idea of what's happening here. So Bob goes to N, and then N goes to account name. So it gets assigned to this one here. There. And then this one, let's change the color. This one goes here to B. And then the value of B goes to balance. Right. Well, hopefully this isn't too confusing. So my arrows are mixed up now, but hopefully you get the idea. And then let's go ahead and remove that now. All right. Okay, and then similar to this first one, because this is also a bank account, then it also has the ability to deposit. We can deposit into it, we can withdraw from it, we can get the balance, and we can get the account name, right? So, oh, and also, so within bank account tester, within the main method, this is identified as B2 because of this. So this is very important, okay? All right, so now let's go ahead and test out the methods. So let me just remove this stuff first. Okay, so let's go back to the code, and then let's go ahead and check for the account name and the balance. So how do we do that? So this first one can be identified using B1. Okay. So we say B1 dot, and then we can go ahead and call the account name method here. We can say get account name. So what's going to happen here is, so B1 is this one, right? B1 is the one with a balance of 2000 and the account name of Alice. B1 has a method called getAccountName. So when we say b1.getAccountName, we're calling this specific method here within the context of B1, not B2, right? Because we're saying B1 here. So that's why the names are important. And that's why it's important that you call the method on the correct object. We can't just say get account name, because as you can see here, we've got B1 and B2. So if you just say get account name, it's going to be confusing, right? Which account do you mean? Okay, so B1 and B2, they both have get account name. As you can see it defined here, but this one is specifically calling get account name on B1. So what is the value of account name here? It's Alice, right? And what does get account name do? It returns the value of account name. So when you say get account name, it's going to check the value of account name, which is currently Alice, and then it's going to return it to the function call. Okay, so this gets returned here. So it gets returned to a different file, which is fine. That's because this is a public method. The field may be private, but we actually have a method here that's public. which allows us to get the account name. And this returns the value to the caller right here. So even if it's in a different file. So again, I hope you're beginning to understand what public and private mean. We'll maybe take a look at more examples in the future. Or if you have any questions or clarifications about it, you can go ahead and ask it in the comment section. Okay. So what's going to happen here is account name is going to get returned to this caller here because this is the one that called it. So this is going to, just imagine this turns into the string Alice. Okay. So once the value is returned, you could store this in a variable, for example. You can say string s1 is equal to b1.getAccountName. So this one, after the method finishes, it's going to turn into Alice. So it's like saying string s1 is equal to the string Alice. Okay. Or you could just go ahead and print it out directly. You could, so right now here, we're just storing it in a variable, right? Then we can say system.out.println s1, or we can say system.out.println b1.getAccountName. But you know what, I actually think I'm going to stick with this one. So I will say system.out.println s1. So this is going to print out the value of s1, which in this case is Alice. Okay. And then we can go ahead and do the same thing for the second one. So we say b2.getAccountName. So this time we're calling account name on b2, right? So b2, because it's a bank account, it's also got the getAccountName method. So we're calling getAccountName on b2 in this specific line. So it's going to call this method. And again, what does this method do? It returns the value of account name. So the value of account name for b2 is Bob. So Bob gets returned here, and then it gets assigned to S2. So we can go ahead and print that out. So let's say S2. All right. So we can go ahead and test this now because we're going to see some output already because we have some print lines in here. So what happens here is we will compile these two classes, and then we're going to run the bank account tester because it is the one that has the main method. So when we run it, it's going to create these two bank accounts. B1 is equal to new bank account Alice 2000. B2 is equal to new bank account Bob 1000. So at this point, nothing comes out because we don't have any print statements associated with these lines yet. And then in the in this line that follows, we are getting the account name of B1, and then we're assigning it to the S1 variable. So again, when you declare a local variable, you specify the data type, but you do not say private or public. You do not do that. You're going to get an error if you try that. And then in the next line, we're just printing out the value of S1. So this is when we expect some output. At this point, when this line gets executed, it should say Alice. So we should say Alice come out in the command line, which is where I'm going to test this. And then this next one gets the account name of B2 and then stores it in S2 and then prints it out. All right. So let me just minimize this, and then I will open a new command line, a new terminal window here, and then I will say javac dot, I'll just say *.java so that it compiles all of the Java files inside the bank account -sample folder. So Java C space *.java. So this compiles the Java files. And then we're going to end up with class files here. So if I check this now, we see that we've got the Java files with the source code, and then we've got the class files in here. And then we go ahead and run the bank account tester file. So that's the one that we run, the bank account tester class, because that is the one with the main method, public static void main string args. So if I run this, I say Java, okay, not Java C. So Java C to compile, and then just Java to run, and the name of the class. Just the name of the class, doesn't say .class, Java bank account tester. If you put .class here, it's going to give you an error. If you put .java, it's going to give you an error. So just say Java bank account tester, just the name. Enter, and then there it is, Alice and Bob. So we get the expected output. So let's go back here. And then let's do a couple more things. Okay, so let's say, let's get the balance. Okay, so let's say amount 1 is equal to, and then we say b1.getBalance. So the concept is the same. So this is calling the getBalance method on b1, which is this bank account here. So getBalance is going to return the value of balance. So b1 has a balance of 2000. So this is going to return, this is going to give us 2000. So AMT1 is going to have a value of 2000. And then you can go ahead and print that out. Let's just use this one. So it's going to say, S1 is going to say Alice. So Alice plus, and then a string, has a balance of, okay, and then we say plus, and then AMT1. So S1 stores the account name, AMT1 stores the balance of B1. And then in this print statement, we're printing out the value of S1, so Alice in this case, plus we're concatenating it with a string. So there's a space here. So Alice space has a balance of, and then a space. And then we're concatenating it with whatever the value of AMT1 is, which in this case is 2000. So our expected output here is Alice has a balance of 2000. Now with Java, you actually can concatenate strings with numbers. So you don't need to convert it into an integer or a float or whatever. So Java will actually just implicitly do it for you. So this is already going to work. We don't need to change that anymore. So let's just go ahead and do the same thing for this next one. String S2 is equal to b2.getBalance. All right. Then we say, let me just copy this. I'll copy this part, and then I will make sure that I change this one, AMT2, and this one as well. I made a mistake here. Double AMT2. So it has to be a double because getBalance is going to return a double. There. Okay. So this is going to print out Bob has a balance of 1000. Okay, so let's save this. And then every time you make changes, you are going to have to recompile. So I still have the same window open, so I can actually just press up and up again. So Java C *.java is going to compile all the Java files in here. But actually, the only thing I need to compile here is bank account tester because that's the only thing I changed. But let's just go ahead and recompile everything. All right. And then let's go ahead and run Java bank account tester. So now our output should say Alice has a balance of 2000.0, right? It's a double. It's a double, even though we assigned an integer to it because this is a double field. Java converts it. And then Bob has a balance of 1,000. All right, so we are getting the expected output. Okay. So after this, let's go ahead and make a deposit. Let's make a deposit to B1. So we say B1 dot deposit, and then let's say 500.45, right? So deposit is a void method, so it's not gonna return anything. So we don't print this out, or we don't assign it to a variable because it doesn't return anything. So what this does is it's simply gonna change the value of balance. Okay, so let's bring back the diagram. So I think I need to move this. Can I move it? Okay, let's move it down here. Let's move this down here as well. All right. So we're calling deposit. So all of our bank accounts are capable of depositing. So all of them have a deposit method. B1 has a deposit method. B2 has a deposit method as well. This specific call to deposit is being called on B1. So this means that this money is going to be added to B1. So what happens here? So deposit is going to get called, and 500.45 is going to get passed to AMT. Okay? So AMT is now equal to 500.45. Let's bring back let's try it again. So 500.45 gets passed to AMT. So again, this is within the context of B1. So B2 is not going to get any money. Sorry about that. Sorry about that, B2. No money for you. So AMT is 500.45. So AMT is equal to 500.45. And then what's happening here? We're saying balance plus equals AMT. So the current value of balance is for B1 is 2,000. So what we're saying here is 2,000 plus 500.45 is equal to 2,500.45. And then we update the balance so that its new value is going to be 2,500.45. So the plus adds to the value, and then equals makes the result the new value. So now Alice's bank account now has 2,500.45. So let's update that. Oops, I erased the wrong thing. That's okay. I can go ahead and draw it again. Okay. So now this is 2,500.45. Okay. So you can call deposits more times after this. You can deposit more money to B1 or to B2. Okay. Let's go ahead and instead, let's make a withdrawal. So this time, let's withdraw money from B2. So B2 dot withdraw, okay? And then let's just withdraw 100, okay? So by the way, you don't have to do this in the same order as when they're declared, right? I mean, I could have said B2 dot withdraw first and then B1 dot deposit. I could have made 3 B2 deposits and then 1 B1 withdrawal, and then I could have printed out, maybe I could get the balance again and then print it out, okay? So in this case, I just added another one, another line that just withdraws from B2. So we're saying B2 dot withdraw 100, okay? So again, withdraw is also a void method, so it doesn't return anything, so it's just actually changes the balance. So the only thing these two methods will do is they will update the balance. So that's what they're designed for currently. Okay, so it just updates the balance and then that's it. It doesn't return anything back. You could make it return the balance again, but if you don't want to, then you go ahead and just put void in here. Okay, or if you don't need to, for example, because we've got the get balance method anyway, which allows us to just get the balance whenever you want to. But again, you could say public double withdraw double AMT, and then after balance minus equals amount, you could say in the next line, return balance. So withdraw not only mutates the object, meaning changes its state, modifies the balance in this case, but the method actually returns the value back to the caller, meaning this line that calls it. So in that case, you will be able to print out this result in the same way that that we are doing here. So we're actually getting the value, assigning it to a variable. Okay. So if we make this return a value as well, then we could assign it to a variable. We could print it out directly. We could put it in some kind of expression, like an arithmetic expression or something. Okay. So that is also possible. But I wanted to show you guys what void means. Okay. So it just means that it does not return anything because the void is nothing, right? Okay, so now we've got withdraw, and then it's being called on B2, so it's being called on this one. So Alice's balance stays intact, but Bob is gonna withdraw some money to buy something. So withdraw 100. It's gonna call this one. So 100 gets passed here. And then AMT is now equal to 100. And then we say balance minus equals AMT. So what is the balance of B2, right? Because we're doing this in the context of B2. So B2 is 1,000. Balance minus equals amount here will result in 900. Okay, so that is going to be Bob's new balance. So let's erase that. And then let's just update. So Bob now has 900. Okay. So now, if we test this out, if we print out the balance again, we should get different results here now because we deposited into Alice's bank account and withdrew money from Bob's bank account. So let's go ahead and do this again, but this time you have to make some changes here. So I did a deposit and a withdrawal, and then what I want to do next is I want to go ahead and print out the new values. So this one, I have to remove the data type. Okay. So the first time I create the variable, well, when I declare the variable, so when I create it, so this is the first time, okay, I need to specify the data type. But if I use the variable again and assign or update the value, oh, in this case, actually, I don't need to do it for S1 because the account name is still going to be the same. So we're not changing the account name. We're not providing any mechanism here to actually change the account name. So we just have deposit and withdraw, which can modify the balance. But as you can see here, we can only get the account name. Okay. So what I want to do here is I want to get the balance again. So at this point, line 8, no deposit has been made yet, right? So when we execute this line, it's going to say the original balance of Alice, which is 2,000. But we made a deposit here. So this means that if we try to get the balance again, it's going to give us a new value. So if I want to print the value of the new balance, so I have to get it again, and then I can assign it to a new variable. So if I want to reuse this variable and just update the value, then I will just say AMT1. Okay, if I specify the data type again, Java's gonna think that I'm trying to declare another variable with the same name within the same function or within the same method. So we cannot do that. We're gonna get an error if we try to redeclare a variable of the same name within the same scope. So in this case, we just want to update the variable. So we just say the variable name and then we assign a new value to it. So in this case, b1.getBalance is going to be 2500.45, and then we assign it to AMT1. So now if we print this out, this specific line is going to say Alice has a balance of 2500.45. Okay, so this first one, so no deposit has been made here yet. So our expected output here is still the same. But this one is after the deposit. Okay, so another option is to actually just put b1.getBalance here. So make sure you type in those parentheses. So this is another option. We don't really have to store it in the variable, but I wanted to just show you that if you want to update a variable, then you do not type the data type again, because Java is going to think that you're declaring another variable, but it has the same name, and Java does not want that. Okay, so you could do this, or you could do that other option, the same, pretty much the same, except this one has one more line. Okay, so you can comment this out and then just say b1.getBalance here instead, but we're going to stick with this one. And then let's do the same thing for this second one, for B2. So again, we remove this, right? It should just say AMT2 is equal to B2.getBalance. And then we say system.out.println S2 plus has a balance of AMT2. So at this point, AMT2 has been updated with the new balance of Bob's bank account, which is now 900 because Bob made a withdrawal. All right, so let's save this, and we need to recompile it. So if you want to just recompile one file, you can just say the name of the file. Okay, but if we made changes to bank account, this is actually going to recompile as well, because bank account tester is making references to the bank account class. So it is actually going to recompile this class as well. Now, I'm just not sure if this is going to recompile bank account always, or if it's only going to recompile bank account if we actually make changes to bankaccount.java. Okay, but I know for sure that if we make changes to bankaccount.java, and if we only recompile bankaccount.tester.java, bankaccount.java actually also gets recompiled, because bankaccount.tester is accessing the bank account class in here as well. So Java's going to know that it's supposed to recompile bank account as well. Okay, but here I just wanted to show you, yeah, you could just specify one file to compile, and then it could possibly compile other related classes as well. Okay, so no error, so that's good. And then let's go ahead and run bank account tester. I made a typo. T should be uppercase. Oops, what did I do? Bank account tester, there. And then I pressed enter twice. That's why we have the line there. Let's run it again. Okay. So there, we are getting the expected output, right? So Alice has a balance of 2000.0, Bob has a balance of 1000.0. So that would refer to this one and this one. And then we make a deposit and a withdrawal, a deposit from to B1 and then with a withdrawal from B2. And then these next two print statements, they refer to this one. So Alice has a balance of 2,500.45, and this one refers to this one. Bob has a balance of 900.0. All right. So that's it for now, actually. So that concludes this lesson. So so what are the things that we did? We created a class. We defined a class called BankAccount.java. So defining a class is like creating a blueprint for a specific object where you define its characteristics by specifying fields and by defining its behavior, the things that it can do by creating methods in here. And then you have the constructor, which allows you to create the object and initialize the values for the fields. And then here in our main method, we made use of the bank account class. We created instances of the bank account class. So B1 is one instance of bank account. B2 is another instance of bank account. So they are instances. I can also refer to them as objects. So B1 is an object. It is a bank account object. B2 is an object as well. It is a bank account object. And then we call the methods of those objects. So when you call a method, you specify the object so that it's going to work on the correct one. So b1.getAccountName means let's get the account name b1, which is going to return the account name of b1. All right. So account name, get account name, and get balance, they both return a value. So the first one returns a string. This other one returns a double. So this means that we can assign it to variables and then use it in expressions. So here we're just printing out the name and then has a balance of and then the amount. And then here we called more methods. So these ones are void methods. They do not return anything. They just change or mutate the object. So they're called mutator methods. So these are mutator methods. These are accessor methods. Okay, they access because they're returning something. They access a field. I mean, they access a field and then they return the value. So you can call them as accessor methods. And then you can call these mutator methods because they change a field. They modify or change the state of the object. So in this specific method deposit, this ends up modifying the balance. And this one ends up modifying the balance as well, but this one subtracts from the balance. All right. Okay, so there. That concludes this lesson. So I hope things are a bit more clear. Definitely more things to learn in future lessons. Yeah, we'll try to understand more of Java. All right. So thanks for watching.